scientific method to real-world examples and research questions. The philosophy of science. There are many reasons to undertake scientific research: a desire to discover a cure for a disease, or a mechanism to change how we use fossil fuels. It may also be a more basic drive to discover new information that has no obvious application. In the world of the 1850s scientist, the desire for discovery was sufficient, along with a generous benefactor, to establish a career and to build on existing information. However, commercial realities of our current world mean that the need for scientific research may be driven by the actual discovery rather than the journey. Nevertheless, the drive to discover something new and potentially important is what motivates many people who are beginning a scientific research career. If we think of those seminal discoveries in the second half of the 19th century, such as Mendel's genetic basis of heredity, Lady Mary Montagu and her use of inoculation, Koch's postulates, and Pasteur's subsequent proof of the germ theory of disease, we may be led to the conclusion that there is nothing left to discover. The work of Koch and Pasteur demonstrated that hypotheses could be tested by careful experimental design and interpretation, and if these results stand up to repeated testing, then a paradigm or widely believed conceptual advance to the field is established. That is not to say that these paradigms are irrefutable, or that science does not undergo repeated refinement and adjustment. As new technologies develop, questions can be answered in different ways, and new hypotheses tested to ensure that each scientific field or discipline progresses to know what has previously been unknown. In that respect, science and scientific discovery is a process by which we continually observe the natural world, form hypotheses based on these observations, and set out to test a variety of variables to prove, or more likely, disprove the hypothesis. Hypotheses are tested by more than one scientist or group, and this allows for integrity of the results, leading to a conceptual framework in which various facts and observations can be placed. For example, the basic tenet of the germ theory of disease states that diseases are caused by microorganisms or pathogens that invade the body. Although the theory was first postulated in the 1700s, it took until 1840 to be able to design experiments to test this hypothesis. Three well-known scientists, Pasteur, Lister, and Koch, provided the scientific evidence to prove this hypothesis, eventually leading to the identification of specific microbes that caused various diseases. The general principle of scientific research is an adventure into the unknown. How does something work? Can I make it work better? What causes this process? How do I find a treatment for a disease? The questions themselves are less important than the fact that one is questioning. The underlying philosophy of scientific research is simply to find stuff out. The scientific method. The scientific method refers to an established set of processes to perform and analyze new scientific research. It begins with a question. What are you trying to find out? Then it moves to a hypothesis. What do you think is the answer to the question that you have just asked? How will you determine whether the hypothesis is true or not? What experiments can you perform to determine whether the hypothesis is true? Will the experiments give you a definitive answer? If not, is there an alternative or parallel experiment that you could perform? An experiment should determine whether the results observed agree or disagree with what was predicted.